Hi girls, I'm going to correct exercise 13.5 now. So here I have the histogram shows the distances in kilometres that some students have to travel to school. So I'm asked to complete the following table, okay? Right, so there's lines going up all the way here. So basically I have to figure out how much is each one of these lines worth. So I have 1, 2, 3, 4, 5, okay? And 10 divided by 5 is going to be 2. So this is going to be basically 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So each one of these is actually worth 2. So it's not a case of estimating what you think the value might be. It is, you have to figure out what each mark is worth. So for the first one, 0 to 2, there was 20 people. For 2 to 4, there's 12. For 4 to 6, there's 14. And for 6 to 8, there's 4. And then finally for 8 to 10, there's 2. Okay, so that's question 1 completed. Then it says the time in minutes taken by each member of a group to solve a problem is represented in the histogram, and I'm asked to complete a table. I don't have it drawn out, okay? But in your table, girls, times minutes, so in 0 to 1, you should have 2. In 1 to 2, you should have 3. In 2 to 3 in your table, you should have 5. And in 3 to 4 in your table, you should have 2. And then finally, for 4 to 5, you should have 1. Okay, so that's all the values that should be inside in your frequency distribution table that you've copied into your copy. How many students solved the problem in less than 3 minutes? Okay, so in less than 3 minutes. These students solved it in less than a minute, less than 2 minutes, less than 3 minutes. Okay, so I have 5 plus 3, which is 8, plus 2, which will give me 10. So part B, the answer is 10. And then C, it says what percentage of students solved it in less than a minute. So these students here solved it in less than a minute. So it's 2 out of my total. So I have to figure out how many students are in this class. Okay, so far we have 10 as far as here. 11, 12, 13. So it's 2 out of 13 multiplied by 100, and when you put that into your calculator you get 15.38% solved it in less than a minute. Then part D asks me, what is the largest possible number of students who could have solved the problem in less than 2 minutes 30 seconds or less? Okay, so what is the largest possible number? So what I need to do here, okay, so these students definitely solved it in 2.5 minutes. These students solved it in less than 2.5 minutes, okay. My largest possible number, I need to include these as well. I know it's between 2 and 3, but all 5 of these could have solved it in 2.5 minutes, okay. So part D, my answer is 10 as well. And now I'm going to correct question 3. Okay, so for question 3, I was told that the ages and years of a group at a party were required. The results are shown in the table below, so this table here. Then I'm asked copy and complete the histogram shown below, so I have copied what they have given me in the book, and I need to now complete this histogram. So I'm just going to get my ruler here. Alright, so 15 to 20, that's 4 people, so I need to go over to 4 and up. 20 to 25, that's 8 people. They already have 25 to 30 done for me. 30 to 35 is 12 people. Okay, and the final one is also already done for me. So that's my histogram for question 3. Then I have question 4. So I'm given this frequency table, and I'm told that the number of hours of sleep taken by 50 people was recorded on a night and was tabulated as follows. Draw a histogram that will represent the data. Okay, so remember I need my 3 very important things. So I need to label my 2 axes and have a heading on my histogram. Okay, so I'm just going to call this number of hours sleep. Okay, so you can come up with your own heading as well. I told you whatever's on top of my frequency distribution table comes straight down below here, and along the side is always my frequency, so number is going to go here. Okay, right, then I have to have equal parts going across, so I'll have here 0 to 3, so I'm going across in inches. Okay, so this here is going to be 0, 3, 6, 9, 12, and my highest value I'm going up as far is 20, so I'm just going to go up in twos, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so I've gone up as far as 20. Now I have 0 to 3, that is 4, so I'm going over and up here. 3 to 6 is 11. Okay, 6 to 9 is 20. 9 to 12 is 15. Okay, and that's my histogram drawn there. Okay, then next part, question 4, it says, what is the greatest possible of number of people who had over 8 hours sleep? Okay, right, they had over 8 hours sleep. So here I have, this here represents 15, this here is 20, this here is 11, and this here is 4 people. Okay, these people, so these had between 9 and 12 hours sleep, so they definitely had over 8 hours sleep. Okay, so I'm going to have 15. I was asked for the greatest number, so these people had between 6 and 9 hours sleep. Okay, but every single one of them might have had over 8 hours sleep, so we can include them. We're not sure if they had 6, 7 or 8, but because I'm asked for the largest possible number, I'm going to include them. So 20 plus 15 will give me 35. So that's the answer for part B. Part C then, it is, what is the least possible number of people who had over 8 hours sleep? Okay, right, these people definitely had over 8 hours sleep, 15, but all of these could have been 6, 7 hours sleep, so that means we don't include them for the least possible. For my answer for C is 15. Now I'm going to go on and correct question 5. So for question 5, I was given this frequency distribution, and I'm asked to draw the histogram for this data. So once again, it's really important I label my 3 axes. Okay, so I give it a heading, and I label my horizontal and my vertical axis. Okay, so whatever's on the top here comes straight down. So I have time. Then along the side, I'm going to have number. And my heading, this is dealing with, so in a restaurant, the times taken in minutes for customers' meals to arrive. Okay, so I'm just going to call it time for meals to arrive. Okay, right, I need to go over as far as 30, and I need to make sure that I have equal intervals. Okay, so this is going to be 5, 10, 15, 20, 25, 30. Okay, so 0, 5, 10, 15, 20, 25, 30. Okay, my highest frequency value in this case is 8, so I can go up in ones. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 0 to 5 minutes was 1 person. Okay, 5 to 10 is 6. Ten to 15 is 7. 15 to 20 is 8. 20 to 25 is 6. And my final one is 2 people. Okay, so that's my histogram drawing for question 5. Then it says, in a popular TV program, a well-known food critic stated that people should not have to wait longer than 17 minutes for their meals. What is the highest possible number of people that could have had to wait longer than 17 minutes? Okay, right, so if they have to wait longer than 17 minutes, we're going to be looking at these people here, okay, so they could have been waiting 15 to 20 minutes, but I'm asked for the largest possible number, okay, so all of these people in here could have been waiting 17, 18, 19 minutes and so on, so I'm going to include them, so it's going to be 8 plus these people 20 to 25 were definitely waiting over 17 minutes, okay, so plus 6 plus these people were definitely waiting over 17 minutes as well, so plus 2, and my answer is going to be 16. Okay, then part C asks me, it says, what is the lowest possible number of people who could have waited longer than 17 minutes? Okay, so the lowest possible number of people that waited longer than 17 minutes, these people had to have waited over 17 minutes, I'm going to include those. Plus also the 20 to 25 had to wait over, so I'm not going to include those. This time though, all of these people could have waited 16 minutes and so on, so we don't have to include these because we're looking for the smallest number. So the answer is 8 in this case.